Okay, everybody, thank you so much for joining us, and for all of those who have been with us over the last couple of days. For us, this is probably the most meaningful time of the year, where we have new students coming to join us and have lots of questions about what the DRL is all about, and we have students concluding with us that are trying to take stock of what they've done through conversations and through discussion and sharing that work with you guys. And this is always, I think, an important time for us, because we invite people to really help us shape what the next year's research is, the kinds of questions we should be thinking about. And the DRL has been in the business for a while, and it's always, I think, tried to foreground a kind of unapologetic belief that architecture matters. It's a time when most people don't think that architecture is important. It's a time where we try to expand the definition of architecture beyond building. And I think it's really motivated by bringing people together. It's a very human project, even if our approach to certain things sometimes can be questioned, how algorithms can be humanized, how technology can be humanized. It's a complex space, but it's something that we enjoy really working with people that are coming from everywhere in the world to come and work with us. So we don't take that for granted, and we take a lot of humility from it and pride, but also responsibility. As we have always done, we've always made this a kind of open event and an invitation for people to come and join. We do recognize, obviously, that it is a privilege to have these conversations. And I think it's important to think about how our conversations kind of unfold over time. So all of these things have been streamed live. Not streamlined. We basically, if you give us 8 hours, we'll talk for 10. If you gave us another day to do this, we would occupy it for sure, and as much Patrick as I or anybody else involved in the program. We celebrate the conclusion of the event by inviting somebody that we feel could contribute and offer a conversation around design research that can speak to practice and its many manifestations. To be honest with you, that could be as much a friend or an enemy of the program, if that is even something that to be discussed. But in this case tonight, to be honest with you, I think it's a very personal one. For the program, for us, Marta joined us for about 3 years. I think she contributed a lot of important conversations and discussions. I met Marta at EAC when she was really instrumental for putting that school on the map, as far as I'm concerned. Her work has always been distinguished. It's always been progressive. And I think it's always been done with a sense of integrity, which, to be honest with you, I value quite a lot, because sometimes people are looking for the fast, the cheap, the fashionable, and architecture is really, really complex, and it's a really tough thing to do. We've invited all kinds of people to come and speak to this, but I think Marta, in particular, is probably the one person that I actually had to plead to do the talk. And I say that from a place where, as generous as Marta is, Marta doesn't like to stand in the front of house. And I think you guys should really both take stock of her coming here to give this talk. She's been stressed about it from the moment that I asked her to do this, and I feel like a strange personal and emotional kind of responsibility for it. But the reality is she does amazing stuff. She's an amazing person, and we love her here. So I'm not going to introduce all the things that she's done. You could read her bio, but please warmly welcome Marta back to the DRL and the AA.
Well, how is that for pressure, eh? Okay, so I'm gonna try to do this lecture not about me, but I will start with me. If just to introduce myself to a lot of people that probably don't know me, where I come from, because I think that what I'm doing now is very much related to where I come from. So we're going to take a little trajectory, just a little bit, and then I'll jump into the topic. Because the first part is really about explaining to you that there was a big time of my life that I was dedicated to looking at digital production and focusing on its potential, because I was part of the generation of architects that started with this. And well, this is a little bit my trajectory, but you see that I did my architecture degree, I did my master's, and then I taught in a whole bunch of architectural schools. The last one being the DRL, therefore very, very dear to me as well. Because after the DRL, I went to do my PhD, and then I started in Amsterdam. So this was the last place I was in an architecture school, because I'm no longer in an architecture school. Sorry, oops, sorry. So how this is going. My keyboard is not replying. Yeah, this is go. But so if this was my trajectory in education, this is my trajectory in practice. And you see that I have never done almost anything without practicing at the same time. And my practice has been very different, from working in a modular construction company to being a design curator to having my own design to production company, being a digital production consultant, but always and always and always being in digital production somehow. And now at the Robot Lab, I put it because it's also practice for me. And these are some of the work that I did when I had my own design to production practice very quickly. But you see, this, by the way, it's 20 years old. It's like unbelievable. Because this was 5-axis milling, complex molding, concrete shapes, and whatever else we were doing already then. Not just to know that it's a long trajectory. This CNC milling for interiors, these patterns, there were no scripts at that time. There was no Grasshopper at that time. We were generating everything ourselves. In a field of 600 fluorescent lights, we did the first scripting using AutoCAD. And we were doing all these design to manufacturing, because every one of these flags was actually unfolded and it was laser cut. And we did an installation with 600 and plus flags for the Kunsthaus. And then upstairs, again, same thing. We needed to do some projection rooms. We used CNC bending, laser cutting to produce this kind of suspended projection rooms. And this is just to show a little bit of my work, but every project that I had, I always took it as an opportunity to explore something. And that's the reality of it. And when I came to the DRL, I was simultaneously teaching at IAC and at the DRL with the same type of project. And there was the belief, or the investigation was, we architects can also somehow determine how do we want to fabricate things, and we can hack into machines, and we can explore material properties and so on. Now is status quo, but then it wasn't. And so that is also quite old already. But at IAC we were doing, hacking into weaving machines and creating our own formwork, doing swarm robotics, depositing very corrosive material over foam. We were doing hacking into CNC machines to deploy some scaffolding with sand, and solidifying, imagining that we could solidify these structures in desert, doing multi-material deposition, some of which were soluble, some of which were not, to create cavities, structures with cavities, doing hacking into a turntable to produce a kind of 5-axis arm that we could bring at the beach, and spray with glue and make structures in the beach, or 3D printing in the air, which had never been done before. 3D printing with clay with a robot also had not been done before. And this was the work that I did at the DRL with some of my students. Here we could really empower the work with computation that was not possible at IAC in the same way that you could do it here at the DRL. Also, the length of the project and the depth, the fact that you could work with a team of students like you have seen today, made the work 10 times better, 10 times more important, and also the kind of platform that the DRL is obviously made it a lot more relevant. So this kind of work we were doing then, speculating on the possibility to use local materials, to use our own fabrication systems and fabricate on site. And that was a very important proposition. Also, projects like shaping phase-changing materials on liquid environments by choreographing the movement of deposition, creating new spaces, fiber winding on our own structures and so on, and also speculating on the kind of housing that we could do. Since then, that was in 2012, I kind of left the planet. And in the meantime, the planet continued to work. Now I could tell you a long story about all the work that happened from there, but here are a few samples of things that were somewhat. This is the time that it takes from absolute experimentation to practice. And just to some examples, of formwork that has been knitted in a machine, and what to say, houses that become full scale from things that we speculated in this same room. I just want to tell you because this is major for me. So anyway, and I myself started to do my PhD, but also I did several exhibitions as a curator, digital production curator. And when I did this exhibition at the Beaux-Arts in Brussels, it really hit me because a difference in making is also making a difference. And that kind of shift to understand what does it mean in terms of the use of materials, the choices that you make, etc., was the beginning of my second part. And today I'm here to tell you about the second part. So that was the introduction. The second part, I want to tell you that maybe you are the first ones in architecture to listen to me. So I'm nervous, of course, because I speak about my work all the time with companies, with people that I want to involve in my work, but not like an audience that is listening to me and evaluating. But here we are. So I moved to the Netherlands. I did not have a home per se where to do my work. And I ended up in a university of applied sciences that is very different than a normal university, at least in the Netherlands, because this is where the doers are all together. They don't think much, they do. Which is okay, because I'm also like that. And I didn't have a home, I didn't have a lab, I didn't have anything. So the Robot Lab is really, I put it together from the start. Is really bottom-up approach because nobody in the university wanted a robot lab whatsoever. So 5 years I spent in the basement of the university, really literally and not metaphorically, without daylight. So I was on the ground creating the beginning of this lab. But now this photo is already above the ground since 2.5 years ago. And really what I intended with the Robot Lab was to create a place where we could connect education, research, and practice, but really, really, really to find the win-win-win between at this intersection. And that is what I have tried to do ever since. We explore the added value of digital production to address urgent societal challenges. We name it like this. The Robot Lab is in the Faculty of Technology. It's all about integration because we have under Faculty of Technology, there are 7 programs: built environment, engineering, aviation, maritime, forensic, applied physics, and biotechnology, so very diverse. But this is the lab now. I have a very great team that is really multidisciplinary architects, some architects, engineers, industrial design engineers. I have ICT programmers, you name it. And basically the work can be explained like this. We We are working in the field of smart industry in terms of the design and production technology that we are using. We are looking at societal challenges, like, for example, the circular transition, and we want to make impact applications for building future cities in a different way. So Amsterdam is our playground, is our direct environment. We therefore take very much at heart what are the goals of the city, what are the municipality perspectives, and so on. One of them is to become fully circular by 2050. And that means reducing by 50% the use of raw materials. And that is easily said. It sounds very nice, but it's very difficult. So because I'm an architect, I also looked and saw that architecture is very much responsible for all the material waste that we have in this planet. So we started with exploring, and to be honest, I never intended to be working on wood for so many years. Not at all. But it's like a thread that it leads to the next and to the next and to the next. I started with wood because I thought that I can convince the dean that I can do something with the robot easier if I used wood than if I used another material. So that's basically it. But I discovered in this process that 62% of the waste wood that comes from building renovations or building demolitions ends up at the collection site in this big pile, and is burned for energy recovery. So, and the other 38% is actually downcycled into chipboard. So basically there is nothing that is reused, or almost nothing. And in the meantime, the demands for wood resources are rising. For example, in Amsterdam, there is a new law that 20% of the new buildings will have to be in wood. So it's a huge demand only in the Netherlands. And what happens is the Netherlands has only 10% of forest territory. So it's very little compared to what we need. And that means that we have to import a lot of wood, because only 5% of the wood that is needed in the Netherlands is actually sourced in the Netherlands. So there is a big question, and for me it was questions like these arise, like, can technology help extend the life cycle of wood, for example? Or can technology help us scale up wood upcycling? Because this what you see here is, for example, the waste that is produced when we create CLT. And any engineered wood product, this is the waste that is coming out of a factory. So in the lab, we have basically, in the last years, and it was never intended, this is what results from a little bit of stubbornness and perseverance. But basically, you could say there was an agenda, that it was to connect Industry 4.0 to the circular transition. And that meant that in terms of material, we would assume from day one that the materials that we were going to use were non-standard. Because if you have a leftover material, it will not come in standard shapes and in standard sizes like you would buy off the shelf. So that is number one. Also, it would mean that of that material, we would need to know what the hell do we have. Because when you look at that pile, you have no clue how much material you have, of what dimensions, etc. Then we would use computational design to basically make use of the data that we get from the material, and basically optimize and make constructions, or make basically propositions that would be able to work with non-standard material stocks. Then we would use robotic production to obviously make custom fabrication, because if all the parts that you start with are different, you necessarily need to build with custom tools or custom processes. And then most recently, we have introduced digital twinning, and we have introduced digital twinning with the idea to create basically process simulations in a way that allow us to evaluate if it's really worth doing before we do it. And then, of course, we do applications. These are only the partners that I worked with in 5 years. I didn't even have time to update this slide. There are many, many more. But it gives you a sense that in a University of Applied Sciences, you cannot do research if you're not doing it with practice. And that is, I find that a super, super challenge, and I welcome the challenge very much, because it is about making it real. And I want to show you very quickly some of the projects because already first we realized, oh shit, if all the pieces are different, then we also need to somewhat be able to grab them differently. So we need to develop new end effectors for the robots. Then we started to do what we call conversation pieces so that people would understand what we meant by the added value of digital production. So here what you see is a sort of lounge chair made out of waste material. This waste material, I wanted to collect it from the collection, the municipality, the collection point of the municipality. I had to make agreements to get that material with the municipality because it doesn't belong to the municipality the moment that you pass the door. So that also made me understand who owns waste, what is about this waste. But anyway, we introduced 3D scanning because we did it all by hand, so we didn't have a clue about where the surface is. So we introduced 3D scanning for the robots, CNC milling, and we just milled the shape a little bit. And what happens is very interesting that when people see the shape once it's been smoothened, everybody thinks, wow, how nice, how beautiful. But actually, 2 minutes before, they didn't give a shit about the other one. So there is where you can explain the added value of digital production. Very simple. You can pay more. Simple. Anyway, we continued with projects, of course, with this idea of digitalization, digitizing non-standard waste streams. We created for us a system of 3D scanning the parts and creating databases of the materials that we have available. So one piece, one entry in the database. And we did already some examples about what we can design with it. But it's really, this was about establishing methodology. So this is a reception desk for the Johan Cruyff Arena, is the Ajax stadium, football stadium in Amsterdam. And basically a very simple reception desk, but where we basically had a database of materials and we could use algorithms and computational design to decide in which position would every piece go. And we could, for example, create a gradient of colors of wood, which you would never do if you were starting with origin wood. Or we could establish that the pieces at the bottom are thicker because they receive more weight, the pieces at the top a little bit thinner, the pieces in the ends a little bit shorter, the pieces in the middle a little bit bigger so that we could zigzag and support the tabletop, etc. Every one of these pieces was actually interlocking with one another with the sequence of assembly engraved in it. And of course, every one of these joints is actually different from the others, and there is where robotic production comes in. The good thing about it is that we could transport it to the place compact. So there was also a notion of reducing CO2. And then basically also designed for this assembly so you could put it apart. So altogether, a lot of the principles that we work with. This is the final desk. I am personally very, very happy about this desk because these were 300 pieces of beautiful hardwood that would have ended up in the incineration plant if they didn't become this desk. So this is when we begin to think about impact, and that's what we do. So, but then when we did this desk in 2021, people said, wow, what a nice desk. Yeah, you know, how long did it take you to do it? Wow, no idea, because we were developing methodology with students, researchers, whatever. It took forever. How long does it cost? No idea. I mean, whatever, no idea. So you are in practice, but you don't have any relationship to the serious business of practice. So the next project, we decided to say, okay, we're gonna take this on. We're gonna imagine that there is an upcycling wood factory, and where basically we start with leftover streams from the wooden industry on the one hand, and the idea is that in the other end, no matter what happens in between, in the other end, there are custom products out of it. Okay, and we thought it's very simple because we have a lab, we have robots, we can do this. But well, the methodology that we are developing, and that by now I think it's established in the lab, is basically like this. You start with a database of residual materials. You use the computational design to optimize and to develop products out of it. You use robotic production and eventually automation to make it happen. And you use the digital twin to simulate the production. And eventually you can calculate your business case and think, is it worth it? Because if this chair or this stool that you're actually making costs 500 euros, you know that nobody will buy it, right? So you need to change things about it. And here underneath is the KPI framework, is the key performance indicator to calculate things on circularity. I will tell you about it in a moment. This is the lab. So here you see, this is our playground. The only thing that is fixed in this lab is this track in the middle, because for the rest, there are production tables, the security fences, there are other robots in the back that can be moved. You can make configurations with 3, 4 robots or whatever you want. So that was also, I designed the lab. I was able to think future-proof as much as possible, with the intention that in the lab, we would be testing the factory setup as much as the design and as much as the material, everything. So we started the project and we decided to start very, very, very simple. So we're going to take a typical Dutch, iconic design. So this is a stool, very, very famous in the Netherlands because it's done by Piet Hein Eyck, is a very, very well-known designer. He has a huge factory in Eindhoven where they are making this stool by hand with traditional woodworking. So I thought it's a very good conversation piece for me. I should take it on. So we started computationally to think about this tool. I thought that we would have it solved in 6 months. But no, because, what happens is that the relationships between the parts, if you are optimizing wood and it turns out that you have wider wood and for example, the top of the stool is made out of 5 parts, why the hell would you cut the wood if you can make it in 3 parts? So the definition of the object is changing all the time because of the non-linear material stream that you actually have. So the idea is this: you have a database of materials. You say, we are now developing, I cannot show it to you yet, but we are developing a sort of interface that you can select. You could say, for example, I only want my stool to be pine. And then you would have just a stool with pine. Or you could say, I want the legs, I want a gradient of colors, or I want the stronger parts like this or like that. So depending on what's in the database, at the end, you have to manufacture the pieces of the stool. And you create an infinite collection of variable stools because they can all be the same. But in let's say, in terms of the outer design, but intrinsically, they will be different. So here is a little bit a show. I show you a little bit how this works, because we are, as we are calling an element from the database and we declare that we are making stool 1, the elements of the database are getting shorter because we have already cut a piece of it. So the database gets actualized and you can, this is a recursive system. And there is a moment that the last stool you're not able to make because the pieces got so short, you cannot make the stool anymore. So the system will tell you you can make 3.5 stools, or you can make so on. So there is, of course, if the database is wider, then you can run this thing all the time. But it's an example of how we are thinking about this. Let's see if this moves. This is not moving, so So now this is in progress. We are also creating a sort of design generator that is more for surfaces. And again, it takes the context. You can declare whatever context you have. You can declare openings, you can declare doors, everything. And you can declare whatever available material you have. It might come in different batches. You might say, I want to mix this with this with this. And then the idea is to make a kind of infill pattern that you can select more or less the idea of if you want a pattern that is made out of hexagons or squares or whatever. And the algorithm will create an infill logic for these panels. And then we are going to get to the part, the information on fabrication on the single part of this. So we are doing a project that is looking at hospitality sector because the hospitality sector is renewing their interiors every 7 years. which is huge. They produce a lot of waste, and they have a high interest in design surfaces. So we thought that it would be a kind of good landing for this. So we are doing a whole bunch of projects as a case study of this project. But here you see a little bit what the design generator can do. And basically, this is a kind of a skewed version of the hexagon pattern. But here you see that there are tiles, but you don't recognize them anymore because the infill strategy is optimizing the wood that you have available. So, and it's able to recognize the borders so that it basically adjusts everything to do this. And this pattern with different thicknesses, with different types of wood, for me has a very subtle and intriguing quality that I think is quite nice. And that is, like in the reception desk, is something that these are the emerging design properties of circular materials that could be activated through computation as well. So we have developed for the lab what I told you before, a KPI framework. We are basically trying to calculate what is the impact that we make. If you are able to make this wall with circular wood as opposed to virgin wood, how much wood did you actually save? You know what? So there is an impact on and of course how many trees did you save, and so on and so on. So we have all these. We have a dashboard, and we are also now this is the digital twin of part of the lab. We are completing now the whole lab, but here you can simulate for real. You can simulate the production, and you can know absolutely everything about it. How long does it take? What's the energy that the robots will use? You know, everything. How many man hours you need because you have the process simulated, and so on. And well, the idea would be that in the end we are able to know the avoided impact of any object that we create, and to know the production impact of every object that we create, so that we can again decide if it was worth doing or not. 2 years ago, I completed another project that is important, is the circular wood for the neighborhood. Well, we are very happy because we won the best research award in the university. But basically, what we did was to look into the waste that comes from demolition and renovation from buildings. What we did was a real survey. What you see here is nothing that we have invented. We went to 15 buildings that were going to be demolished. We calculated, we measured every single piece of wood that was coming out of the building to just determine what was valuable wood coming out of it and where would it end up. If we didn't do anything, where would it end up? And there is where we know that 2/3 will be incinerated and 1/3 will be downcycled. What we did then was this is the basement, by the way. What we did then was to also show, because at the moment, wood upcycling from construction is not happening because it's too expensive. It requires too much human labor. So we thought, well, if you can do it with robots, then eventually this could be a good use for robots. And well, we proved that some parts could be done by hand, some parts could be done by robots. Again, we did conversation pieces because we do that all the time. We showed that it's possible to remanufacture, for example, these are profiles from old windows. And of course, we had to make a window that is all crooked just to get people talking, because if you have an original window and you have the corner that is damaged, you cannot pretend that you can do the same window with half the wood that is damaged. So this was, and of course it gets everybody talking. This is what you see here are a series of front doors. By the way, in Netherlands, much of the architecture looks alike. So when you dismantle things, you actually get series of elements that are all the same. So here, what you see here, these are front doors from normal houses that you can pull apart and you can create new design systems from it that are very interesting because you can do parametric stuff with it. So in this project, we did 3 case studies, and because we had as partners housing corporations, And housing corporations are social housing in the Netherlands. We worked with two. Together, they had a park of 120,000 apartments in the metropolitan area of Amsterdam, so huge housing corporations. And basically they told us that all their housing park is basically three types several types of housing, but there is a type that is this one, when there is a series of row houses, a few, and the neighbors here, they know each other very well. And we thought, well, if you are doing a renovation in this case, maybe we can do an object, a piece of furniture for every one of the neighbors, so that at least, it's like from my door to my coffee table, kind of, so that there is a kind of a raising awareness on circularity. So here is the coffee table made out of the door. With a happy, and we think that it can be interesting because every one of the coffee tables might be slightly different, and it gets the neighbors to be more active with each other. Then there is another case, which is when there is such a big building that many people are living in this building. There is a sort of anonymity; people don't know each other. And housing corporation says that these are the buildings that are more costly to maintain. And because people don't care, they don't feel that is their home in any way. So maybe for these people, if the facade, for example, was going to be renovated and all the windows were going to be changed. Oh, by the way, the windows are only are changed in the whole facade when 40% of them are damaged, but the other 60% is still good. Because housing corporations anticipate that if 40% are damaged, the rest will follow, right? So, but we thought, well, wouldn't that be a great proposition to actually say, wait, give us the windows and let's make a community structure, a collective build-up, because we know that when you build something together, it connects people. And it connects people to the place, and it improves the urban area where they live, and most likely it will improve the value of the building as well, and it will reduce the cost on maintenance. So, basically that's what we imagined, and this is what we were imagining. The vision of this would be something like this. And last but not least, the last case study was about convincing the housing corporations that they could do a kind of material bank, because one problem that happens is that if you renovate a building today, the wood that comes available from that building is not immediately available for the renovation. So you need to put it on storage, you need to process it somewhere else, and that costs money, and that's why nobody wants to do it. So if housing corporations could work with each other and create shared material banks, there would always be available material for any one of them to do whatever they have to do. They could bring in material and they could take material when needed. So that was the proposition. This was in the time of pandemic. So also we were affected by it. That's why the case studies became virtually represented. But in this case, we were seeing that in the pandemic, the use of space is also needs of a reconfiguration. And we thought that it would be interesting when you can use this kind of wood to do this kind of stuff. And this is what brought me to a project that we're going to start soon. This is not work from us, but this is the vision of it. Because it's a beautiful picture, because I think it speaks 1,000 words. Imagine that this wood that is here, this is done with virgin wood, by the way, but imagine that these were your windows before, and that you collectively had created this sort of playful playground or whatever structure in the middle of this neighborhood. I think it would be wonderful. So this is Amsterdam. This project is located at the Van Dijsselbuurt. It's just a little bit outside of the ring. It's one out of 20 vulnerable neighborhoods in the Netherlands. Not even in the city, it's in the Netherlands. So it's a really shitty neighborhood. It looks like this. This is the typical construction, standardized, multiplied, etc. And funny enough, 95% of these buildings are owned by the same housing corporation. So there is a great opportunity. There is only one client, if you want. So, and they have a 10-year plan to renovate this neighborhood. Half of these buildings will be demolished and the other half will be renovated. So there's going to be a massive quantity of wood coming out of it. And they have not yet designed the spaces in between the buildings. We saw it today, so much conversation about the spaces between. So there is an opportunity because maybe the wood that comes available could serve to create pergolas, to create benches, to create whatever. But all the kind of infrastructure that you could give back to the community for the drama that they go through, because half of these people will be displaced because their building will be demolished, yeah, and the other half will be moved away temporarily because their building is being renovated. So if through this project we can connect the community, I think is very good. So the proposition that we have at the Robot Lab is that we are going to move part of our equipment to the neighborhood, and we are going to basically this is a picture that tells the project, which is we're going to be on location where the wood is being harvested. We're going to be working to process the wood on location. We're going to be storing it or making it available, and we're going to be building with the citizens of that neighborhood. We're going to be building structures that we might have co-designed with them. That's it. And then that brings me to a project that we have also ongoing at the moment. Is a EU Horizon project. It's called Wood Circles. We are collaborating with a whole bunch of people in Europe. It's actually a project put together by the Danish Technology Institute. We were invited to develop, you see here, the idea of the project. The big idea is to basically take wood from what they call the urban forest and take wood and basically process it in a robotic type of factory, process it into baseline materials to generate or to be able to create engineered wood products like CLT or glulam or things like this, and then basically develop a beam system of a building construction system that is made out of these wood engineered elements, but can also be disassembled for reuse. So eventually this gets full circle. So we are in charge of the urban sawmill, this idea that you can actually bring in waste wood resources and that it somewhat in this magic box process it and then basically create several outputs in terms of baseline materials for construction. Basically, the CLT that we are looking at, we are thinking about. We're working with CLT manufacturers, but they have the idea to basically place waste wood in the layers in the middle. And for that, it needs to be inspected. It needs to be, much of it needs to happen in order to bring it to production. So really, at the end, the role of the Robot Lab, at least one part of the Robot Lab, we will be responsible for inspecting waste wood and basically outputting standard elements. So it's very interesting because we start with a non-standard stream and we have to standardize it on the other side. So everything is about custom fabrication and custom production, everything about it. And of course, there is many things, this is just a few, but many more things that need to be inspected in waste wood because there is metal, there is cracks, there is, damages, you name it. It's very, very bad. So what we are doing is really because we learn from practice, what we do is we just go around and see what's happening in the Netherlands in terms of upcycling wood. Because if it's not happening at a massive scale, it's because we also want to understand why not, right? Why is it so difficult? And we have surveyed a whole bunch of companies. We have seen that nobody does the whole process of going from waste wood to a standard baseline product on the other side. And basically, I'm just going to show you a few things. This is us on location. This is one day in the office for us. So we are talking to people, we are investigating how they pull nails, what do they do, how do they know if there is a crack or no crack or whatever. We are visiting companies that are already beginning to harvest wood from construction to make products as well. So for example, these are profiles from wooden door frames and beams and etc. We are also, this is a collector, a waste collector that is starting to sort different pieces of wood. Is a pilot project in the Netherlands, and here I was lucky to be at the auction, or at the moment that they offer it to different manufacturers, to see if we could collect this kind of wood, would you like it, and what kind of conversations and how much will they pay for it, if they pay anything, and so on. And then visiting companies that are indeed trying to make new products by finger joining different pieces of wood and creating boards and that basically end up in this kind of furniture. So I show you this video. If you were in my team, if you were with us, that would be a day in the office. Not always, but very often. And I just want to... Maybe it's not.
But doesn't matter.
Yeah. Be given a professional insight.
Here you have some nails. This is a little problem.
Yeah.
Yeah. So we do it. He's taking some tools, and then I show you what we do.
Thank you.
Wait a minute.
This come to you from?
Buildings, schools, houses.
You harvested, or somebody else did harvest it for you?
Somebody else.
Okay.
So
And you don't give them any instructions. You say, just bring me the wood, however it is.
yeah,
Don't do anything.
They take it out, mostly by crane. The nails inside.
This thing is what they have on location?
Now, come.
This is how it comes to you?
Yeah.
Yeah.
This is how it goes.
All right.
And then they throw it, and a lot of times now we have a lot of people, they make it like this.
Okay, so they basically empty the container
Empty the container here,
and they drop
full.
all the wood,
everything.
and some of it might get broken.
Yeah.
It's a mess,
Yeah.
basically.
Big man.
A big mess. And then you have people,
Yeah, but then when you have screens, put them in.
yeah, like that.
Like that.
Yeah,
And
you
then
do
the
here.
people are working here and taking out all the screws, the nails, everything. And then they go to we cut them off on the length that we want. So you see that is beautiful to sell it again.
Yeah, so this is the end.
This is the end.
Okay, so we are gonna follow the whole thing.
Yeah.
So it comes in a container. They
Yeah.
drop here all the mess, and what you're going to demonstrate there is what they do here.
Yeah.
Correct. Okay, so basically learning by doing at its best. I mean, we're just going for it. And we are asking questions and people are wondering what the hell. But I just want to show you that we are basically slowly but steadily moving into a domain that is not designed to production, but inspection to production. It's a new category almost. And because, this is an example of, if you have robots to do things, you have to decide what are they gonna do. And if you have 20, you could pull nails with a robot. We are gonna try it. We're gonna do it. But if you have 20 nails to pull on the same side of the beam, you might decide, really, you do the digital twin of it and it's not worth it. It's too expensive. That beam, the material cost for that beam prevents you from doing it. Because if you have to pay more than what you would have to pay for a piece of wood that you would buy off the shelf, then you should not do it. It's simple. So, and therefore you might be programming the robots on the basis of your inspection, which basically means in this case we might just cut and get rid of all the nails, because we are saving wood on the other side that is really worth saving. So that's what we are doing, kind of re-engineering how we can do digital production or timber robotic production on the basis of its inspection. So, of course, in the lab, we work with technical partners. We are developing now our own inspection system. I cannot talk about it because it's part of the EU Horizon project, and I have it forbidden to give the details about it. But here you see us at a company that works with us for smart factories. They have all kind of sensors, all kind of cameras, all kind of things, tools and toys to put together and to learn what is underneath, what is on the conveyor belt. And of course, there are applied AI models that will know it's a piece of chips, it's a bag of chips or is a bottle of milk, you know? So all of this we are doing as well, because if I want to recognize if there is a bracket or if there is a screw or if there is a nail or if there is this or if there is that. So that also, these kind of models we are also developing in the lab. And that's basically, I'm coming to the end, but we are supposed to design an urban sawmill that everybody, absolutely everybody, conceives as a central factory, big factory, where all the material goes to. We, in my team, we are not convinced that this is the solution. And we think that maybe indeed you can upscale more and you can make more impact if you decentralize the technology and you bring it on location. And I wanted to show you this because in many ways, this is what I did at the DRL, to bring technology on location and work with the material that is there. Because if you have to transport all the wood, knowing that much of it is actually waste, then you are paying extra and you are doing a lot of CO2 emissions that is maybe not worth it. So when there is a challenge, if there are challenges, we love it. And as you see, one challenge leads to the next. And that's why we work for so long in circular wood, because we still find it very interesting. We have many open questions. But when we have a challenge, I do this very often, we just get into a bus, I take my whole team, and we are going on a field trip. And here we are, and we look for experts, and we keep on asking questions because the questions and the answers are probably there. And last but not least, we are also beginning to, well, it's been a while, but we are testing a way that we can we are streaming back to the lab to our students, because we cannot bring everybody into the bus. And not all of us can be at every location all the time. So we are streaming back to the lab the kind of questions and whatever we have. Also, they can send us questions live so that we can ask the questions that they have. And well, this gives you a sense of how it looks like when we go. When we go on a trip. We are also with our audiovisual team, and we have made movies, and we have made live connections in every one of our field trips with our community. Because the intention is to share and is to learn as a community, because no one has all the knowledge, and it's very clear in our team, and it's very clear with our students, and that's what we like to do, to work in a non-hierarchical way, work middle,
selected all the pieces for
very young students that are working in wooden
large tree, less defects. Now,
sciences, but they know everything about wood, and I have a PhD and I almost know nothing. So basically that's the story. Knowledge is shared, it's in the middle, work speaks, and nothing else. That's it. Thank you.
Marta has offered to take questions, if anybody has. This is called the microphone, and if you use it, she'll hear it and everybody else on the recording. Any questions?
Well, really nice to see a great career and great project. And we have to talk later how we can work together. But when you do these KPI simulations, I was wondering what scenario apply to that. Is it a future scenario where you have a degree of automation? Okay, yes. And are you also considering, not only you said you compare to the cost of an off-the-shelf piece, are you factoring in some kind of carbon credit as well? Also, so this is accounted for.
Not yet. But it's clear.
This would be, otherwise it's a tougher margin to hit. Okay. Yeah. I also feel that some of the products might actually have an added value. It's hard to quantify, but let's say you could push out a little bit to let's say the point where you say it's not worth it. So
yeah, and thank you for this, because actually, as I said, the idea was to start with that tool, just as a get your muscles working, and then begin to design any kind of things that we would be able to do with residual wood. And because we would have the automation worked out in the lab, the factory worked out, we could easily then produce these objects. The reality is that we spend a lot more time creating the automation and the communication with the database, because the database contains the manufacturing instructions for every one of the objects that you create. And to set up the infrastructure to do this vision has taken the 2 years of the project. So I cannot show the design opportunities that come with it. But I believe that this is only driven by design in my case, because I think it's very clear that when you are, you have to be creative with the wood that you have. And also the system, for example, could propose you structural solutions that are better than the one that you propose, or better or different. So I think that most of the work, the generative type of work that is typical of the DRL, would be very, very welcome in the next phase, ensuring that we can produce those things in the lab. Because we have created all the communication between the robots, because we basically have put together the infrastructure to make it happen.
Thank you, Marta, for a very inspiring lecture, and especially for our upcoming workshop that we are working with wood. Early on in the presentation, you mentioned one of the performance metrics of some of your joinery was to be disassembled. And I wonder that thread, in terms of using upcycling the material, is there an intention? Have you put focus on the idea of how would you design the assembly so that there will be more upcycling cycles, and that essentially this wood will have many, many lives. So when it comes to be deinstalled again and reused in a different way, that will be facilitated by the joinery that you design.
Yeah, in the European project that we are doing, we have partners, architecture company from here, from London, WTA. They are designing they are doing the building system design for this assembly, and they are really working with companies that are doing joinery for engineered wood products to explore how to put together pieces that, once they are put together as a building, and if there is damage in one of the parts, that you cannot dismantle the building, and you have to be able to remove a part and be able to place another one. So all of this is a lot of, they are doing an incredible job at basically detailing and thinking of systems for this assembly. And well, I think that we're going to learn a lot from it. When we did the desk, there were no, let's say, connectors. It was just wood to wood. It's very difficult because, this reception desk, we learned everything that we needed to learn with that desk. Because as beautiful as it is to have a gradient of colors with the wood, that also means that you have a whole series of species we didn't know then, now we know, that behave differently. And that means that also there, you think that things are going to be easy. You're going to come, kit of parts, I go on site, everything matches, but no, because they move and wood is alive. So there will be, I think that the next, when we are doing this inspection, for example, now, we are also looking at warping, what shape things are in. And I think there's going to be a lot of subtle but very beautiful opportunities that emerge from the fact that we can inspect it beautifully in terms of where is the flexibility, right? And here Japanese joinery and everything, but working with multiple species that have been under multiple environmental conditions, that have been treated differently, that have been harvested differently. You name it, I'm not sure that is that easy, actually.
Super inspiring, and thank you very much. But in terms of the inspection, I mean, it's really interesting to see how you're using inspection for production. Are you also using inspection for insurance purposes? Because there is the certification and in the end, it's a liability problem, right? In most of those cases. And I was just wondering where you are at on the insurance side.
Yeah, very nice question, because it's very, very actual for us. We are now in conversations with an engineering company in Rotterdam that are specialized in secondary timber. And because for example, we wanted to work with Arup. Arup was partners in one of our projects. We wanted to to make a structure out of circular wood, and Arup said no, unless you can strength grade every one of the elements and da. So, and by then we didn't have the strength grading tools, we didn't have the knowledge, we didn't have anything. So it's possible, but there are some conditions. There is, in the Netherlands at least, there is not yet a law for how to inspect secondary timber. There is for metal, but not for timber. And then, we are also, let's say, in the case of the European project, if you see the diagram coming full circle, right? So when you disassemble the pieces of architecture that are made with engineered timber, there is, one possibility would be, okay, I'm taking the elements of engineered timber and I'm cutting them back into the original lamellas, and I use the lamellas to do new CLT. And then in that case, I basically invest again in production. But the other possibility would be, no, we're going to inspect it. And if the elements are okay, why not use it one-on-one? So these kind of questions, I think we're going to also tackle in this project.
Super interesting.
Pass it to me and I can take the walk. Anybody? Going once? I'm just going to say that I think the work is amazingly inspiring, Marta. And I remember when you were here teaching with us, one of the taglines at the time was complexity for free. And it is a demonstration that complexity doesn't really come for free. And I think what I always have valued, and I think Patrick and the rest of the team will share, is the fact that I think you've always gone into I had a question today from a student from another program that graduated who asked me about, how do you continue design research, space, all these kind of things. And there is no natural fit for what research means in practice. And I think, today is a way of also demonstrating that reality is something that we have to somehow invent and find the spaces to somehow instrumentalize and reintroduce the knowledge sharing. It's something that we were talking with Jan during the lunch break, and finding ways to really work on these amazingly complex and strategic challenges. Mm-hmm. Because everybody kind of talks, and maybe that's the thing that I find most disappointing in our profession, is that everybody's selling. everything. You know, it's the issue about how we actually systematize, why we're using computation, you know, always seems to come back to a very particular thing because we need to. The problems are complex. We need to find better ways of doing things. And the challenge is even something as simple as the stool, I think, tease out so many issues, which is the difference of actually doing it versus the assumptions that one makes of how easy something could be and maybe not worth the time. So I think for me it's a very appropriate and a very important talk. I think it's important in this space. It talks a lot about this recently, but somehow is still very thematic. So I think the investment in actually working through these problems that are very everyday is very meaningful, and that's why, to be honest with you, I'm happy in the effort to convince you to do this, because I think it's a very important conversation that needs your trajectory, and I was happy that you spoke a little bit about the path. At the time that Marta was with us, maybe something that should be known, Marta really does believe like running to the people with the big machines, helping them build those machines. At the time it was with Enrico, Dini and D-Shape, where Marta was running to look at these large concrete printers, and I think that same spirit, I think, is very clear, I think, in the talk today. The questions are different, and I appreciated the fact that you showed, you know, in those last 10, 12, 15 years, whatever, some of these things are picked up, so that the conversation about the status of where this projects begin, end, doesn't somehow see them just as student works, but they see it part of a larger conversation that's happening. At the time you were here, even as recent as maybe 10, 15 years ago, that conversation was much more conversational. You had people really collaborating, events that were much more discussion. It's very beautiful to see this space with people in it, but this is not the daily life of this space. And so I think, at least for me anyhow, it's really important that it's not just students, it's people coming back, it's professionals, it's people that are not architects, and that we can invest, I think, the time and the labor to really share not only our knowledge with these things, but actually, you know, to try to find a better way, because I think it's inspiring to actually see your work.
Thank you.
But I think it's much more inspiring from the point of view that you've been committed to it, even if there wasn't a plan. You created a plan, you created the conversations, you're speaking to the people, and I think this point that Patrick brings up, I think is the next step. And maybe our next workshop next year should be taking that on board, and maybe that could be piloted in a small way, and we can continue the conversation. And I'm just saying that mostly because I think it's more about creating the opportunities than expecting them. So people think that research grants kind of like fall into it, and you become actually just a slave of trying to get money. I think one of the things in the DRL or at least I took the position, maybe it's because I'm very naive, is that money doesn't matter. I mean, of course it matters, but when you have nothing in your toolbox around here, and you still want to talk about 3D printing, you don't worry that you don't have a DPL lab, you just make it. Mm-hmm. And I think that do-it-yourself culture, I think, is very important for the students, because they're going to go out in the world and have to create those things for themselves. So I think having you speak to this, having all of us kind of sharing at different forms of what practice is, I think the best thing that we can offer as a conclusion for the 2 days. So,
well, think of the Robot Lab as an extension of the DRL, and that will make me happy.
We do.